In this second part of our lesson, we're going to take a look at exponential functions and how to determine whether they're growth functions or decay functions. So I want you to go ahead and pause the video and take your notes. So let's take a look at growth functions. What is a growth function? A growth function is one in which the value of our function increases, so our y value increases, as our x value increases. And you can also tell that it's a growth function is if in our equation here our a value is positive. So if this guy is positive, then we can take a look at our b value to see whether it's a growth function or a decay function. So what is an exponential decay function? It's an exponential function where the value y decreases as x gets bigger. So you can tell it's a decay function if a again is positive. And we take a look at this b value. If our b value here is somewhere between 0 and 1. For any exponential function that has not been translated or transformed, it has a y-intercept of 0, a. And I know this because if I plug in 0 for x, my b value becomes 1. Anything raised to the 0 power is 1. 1 times a is a. So when I plug in a 0 for x, I just get a out. And so my y-intercept is 0, a. The domain for an exponential function is all real numbers because I can plug in negative numbers, I can plug in 0, and I can plug in positive numbers for an exponent. And then the range of any exponential function that has not been translated or transformed is going to be y is greater than 0 because as you saw in our graph always lied above the x-axis. Alrighty, so let's take a look at how we can determine whether an exponential function is a growth or not. Well, first off, we need to take a look at our y value and make sure it's positive. And in all three of these cases, 12, 0.25, 11, and 3, our a value is positive. So now all we have to do to determine whether it's growth or decay is to take a look at our b value. If our b value is greater than 1, it's growth. If it's between 0 and 1, it's decay. So here, our b value, 0.95, is between 0 and 1, so this is a decay function. This guy right here, our b value is greater than 1, so it is a growth function. This b value here is bigger than 1, so it's a growth function. And then this b value here, 0.75, is between 0 and 1, so this one's a decay function. Now let's take a look at our word problem here. In a word problem, we're going to take a look at keywords to see if our word problem represents something that's going to grow or something that's going to decrease in value over time. And this word problem talks about a college savings account. And it says that you put $2,000 in a college savings account for 4 years, and the account pays 6% interest annually. Well, we know when we stick money in the bank and it earns interest, it doesn't, it grows, the money in the bank grows, it doesn't decrease, or else we wouldn't be putting our money in the bank. So this represents a growth function. Okay, if you saw words like over time decreases, then you would know it was a decay function.